Yes. Okay, we are going to start the class now. Yeah, good morning. All right. So now, where did we stop yesterday? We'll have a check. Yeah, we are trying some programs using classes and objects. So what were the programs? Let's have a check. So we tried these programs. Yes. So now let's learn it from here. Yeah, we have learned. We are supposed to learn constructors. Now, what is a constructor and why we need it? I'm going to explain this to you. So please pay attention and learn. A constructor, okay, I'm going to write it as const, okay, is simply a function, simply a member function of a class. Okay, right? It is related to the object of the class. Object is also called as instance of the class. Okay, right? Since it is related to an object, since it is related to an object, it must not be mentioned as static. What is this? I'll let you know. Okay, right? Thus, a constructor is not a static or class member. It is an instance member. Okay. Hence, it is also called as instance member. Okay, right? A constructor is called as soon as an object of the class is created. Okay, as soon as the object is created, the constructor is called. A constructor is usually used to initialize or construct an object. Okay, how? By specifying the values to the variables of the object, or you can simply specifying the values to the instance variables, okay, or object variables. Very simple. Okay, a class can have more than one constructor. That is, a constructor can be overloaded. Okay, next, the execution machine would recognize the constructors of a class by its name. See, what did I write? A constructor of a class is simply a function, okay. So when we have written tens of functions, so many functions in a class, okay, which of the function is a constructor we should know. Which of the functions that we have written in class is a constructor, okay, is what we have to, isn't it? Right. Okay. All right. Okay. So I hope you are trying to understand. Please go through the points that I have written, and I'm giving you 30 seconds because the next few points that I'm going to write are very important. Okay, all right. I'm going to continue. The execution machine would recognize the constructor of a class by its name. So the constructors, so all the, we can say all the constructors of a class must have the same name as that of the class. So this is very important. Okay, if you wish to create objects for the class outside the class, then the constructors of the class must be in public section. However, please note that few of the constructors of the, okay, or please note that the different constructors of the class can be put into different sections of the class. Okay, right? Okay, mean to say, say suppose if there are 5 constructors in a class, 2 I can put it in private section, 2 I can put it in public section, 1 I can put it in protected section, and so on. Okay, so all this, depending on the requirement, we do this. Okay, however, usually 99% of the cases the constructor will come under public section. Why? Because the the users of the class will create the object for the class and use the class, okay, and use the solution, right? Okay, now next is a constructor cannot return a value. Okay, why it cannot return a value? Because there is no use of the return value, okay, or there is no way for us to hold the return value. There's no such syntax. So the good thing is better to say that a constructor cannot return a value. Thus you must, and hence you must not mention the return type for a constructor. Okay, a constructor cannot be overridden, and hence it cannot be virtual. Okay, right? In Java, a constructor cannot abstract, final, and static. None of these three can be applicable. None of these three are applicable to constructor in case of Java. Okay, static is not applicable in C++ also. Okay, right? So abstract is to say that the function is uh, a polymorphic function, or in other words, it can be overridden later. So mean to say, just like virtual. So abstract and virtual is a little similar. Okay, and final is to say that the function is can never be overridden. And final, constructors in a way they have the final keyword implicitly in them. Okay, as if they are already final. So mentioning final again would be would hamper the very essence of the programming. Okay, right? So now next, in case of inheritance, the call to the constructors of the classes in hierarchy is from the child towards the parentmost, the call, okay, but the parentmost class constructor runs first and then its immediate child class constructor, and so on. Okay, in the case of inheritance, the call to the constructor of the classes in hierarchy is from the child class whose object is created towards the parentmost. So we will learn this because this point would be ambiguous until we practice some program. Okay, right? So we'll leave it later. And next is to initialize const instance members and reference members we use initialize list. Okay, so we have something called as initialization list in case of C++. Okay, and lastly we use the initialization list to uplift the values to the constructor of the base class. Okay, so I mean to say, to send arguments to the base class constructor that we received for from the client class, or say client function. Okay, so we use the initialization list. So we'll save this. Constructors. Okay, so come again, we'll read this once. A constructor is merely a member function of a class. Okay, it is related to the object of the class, hence it is also called as instance member. Okay, since it is related to an object, it must not be mentioned as static, because mentioning a member of a class as static makes it class member and it is not related directly with the object. But a constructor is directly related with the object. Why? Because a constructor is always called as soon as an object is created. Okay, thus a constructor is not a static member. Okay, it is non-static member. A constructor is called as soon as an object of the class is. So this is very important. The fourth point is most important. A constructor is usually, so a constructor is called implicitly as soon as an object is created, means it is called implicitly. Okay, so it is called implicitly. We cannot call the constructor explicitly. Okay, a constructor is usually used to initialize constructor of an object. Okay, right, that is object will have some variables and we want those variables to be initialized, so that we use the constructor. Okay, right. So how do we do it? By specifying the values to the variables of the object. A class can have more than one constructor. Okay, so I mean to say, since, and also what next point says that a constructor must have same name as that of the class. So I mean to say, when you are writing so many constructors, all will have the same name. Okay, right. So now you know what is function overloading. So overloading concept actually came because of the constructors itself. Okay, the execution machine would recognize the constructor by its name. So all the constructors of the class must have same name of that as that of the class. Okay, next, if you wish to objects of the class, for the class outside the class. So we have written a class, and say suppose in some other class or in main function or some other function we want to create object of the class we have defined, then the constructor of the class must be in public section. Okay, right. Why? Because when as soon as an object is created, what happens? The constructor is called. What is a constructor? It is also a member of a class. So to access it from outside, so where it should be placed? In the private section. If it is placed in the private section, then from outside we cannot access the private members of a class at all. So please note, if you want to create an object of the class in outside the class, so then the constructor must be in the public section. Okay, a constructor cannot return a value. Now it does not have capacity to return a value as other functions have. Not just the constructor, we will discuss about the destructor later, which also has no capacity to return a value. Since it does not have the capacity to return a value, so mentioning void as the return type will again be not worth. The reason is we already know that the function cannot return a value, so better not to mention the return type. Okay, right. And in Java, a constructor cannot be abstract, final, static. Final means the function cannot be overridden. Implicitly all constructors are like final methods only. Okay, and next, in case of inheritance, the call to the constructor of, okay, in the case of inheritance, how the constructs work is interesting, which we will see it probably later in case if we have time. Otherwise our intention is to actually learn the data structures. Okay, so now what we will do, we will start writing programs on data structures. Okay, right. uh, Now next is to initialize a constant. Yeah, there is initialization list concept which we use with constructors. The initialization list is used is for 3 to 4 purposes. First is when one of the instance variable of of a object is constant. Okay, so we have to initialize some value, which we will do it in initialization list. And next is say suppose if we want if we have a reference variable inside as a member of the object, so to initialize it we use initialization list. And last use of initialization list is that once we have received, once the constructor has received some values from the client function means say some other class or main function, etc., we want to pass these values to the constructor of the base class, so then we use initialized. Okay, fine. Now we will write the program now. Okay, yeah, so the program that we are going to write would be program to implement stack using an array. Okay, using an array. So what we will do, class stack we will write. So stack, what it will have, it will have an array to store the elements, correct? So let the stack be of type, yeah, int. Let us make it very simple. I'm giving the name as stk. Let the size of the stack be 5. Okay, then what else the stack will have, it will have sp, stack pointer. Okay, you can also name it as top or toss is top of stack. Okay, or sp, stack pointer. Okay, so please note this will come under private section. Okay, so there should be a semicolon of the declaration of the class. Okay, right. So now see that why the semicolon, because in C++ we can create global variables. Okay, so here only we can create one stk1. Okay, right, so or s1, so we can create an object of the class then and there. Okay, so that will become a global variable, global object. So we should not create global objects. Okay, so let's now write the public. So here what are the operations that we can do? Push operation, correct, void pop, then void display stack. Okay, so let these be the operations. Okay, right. Now this is called as class declaration. So please note we have not yet defined the functions. Okay, so this is class declaration. This is not class definition. Yesterday we wrote, what we wrote was class definition. This is class declaration. Now we will define the class. So defining the class is nothing but defining the functions of the class. So void push. So now we are defining the function. Please note in C++ we can have global functions also. Global functions means those functions which do not belong to any object. Those functions which belong to any the functions that does not belong to any class. So here the constructor the compiler will treat this function as a push is a global function, but it is not a global function, it is the function belonging to a class stack. So we have to say that this function belongs to the class stack by writing stack scope resolution operator. Okay, so this is scope resolution, is resolving the scope. So it is telling that this function push belongs to the class stack. Okay, right, so it is a member function of the class stack. So now when we cannot push an element to the stack when the stack is full, correct, when the stack is completely filled, then we cannot then we cannot push the elements. Now how can we know that the stack is full? Okay, see here, So this is the array we are taking, okay, of 5 elements, okay, right? 1, say 2, say 3, 4, 5. Okay, so there are 5 elements here in the stack. Okay, we have named it as STK. Okay, right. So there will be a stack pointer. Okay, what is the name of this? SP. Okay, so this is stack pointer. Okay, so this will be at the beginning -1. Okay, so this will be at the beginning -1. Why? It is not pointing to any element. Okay, right. So it will be pointing here to the first position, mean to say there is one element. Okay, right. So this is the index 0. Okay, so this is index 1, this is index 2, this is index 3, this is index 4, isn't it? This is index 4. Okay, so now when the stack is full means what will be the value of SP? It will be, isn't it? So when SP is here 4, the stack is full. When SP is -1, the stack is empty. When SP is 0, there is one element. I hope you have understood. Okay, so what we'll do here, if SP equals 4, so what we'll say, we cannot push the element, right? So we will say, well, stack is full, cannot push an element. Okay, written, that's it. Okay, so we need not have to do anything there. So here what we'll do, SP++, because now the stack is not full and we can enter the elements, but SP is -1, which we should not use it as index. So what we'll do now, cout enter an element to be, enter an element, or you can say number, isn't it? Right. So enter a number, or you can say enter the number to be pushed. Okay, so here what we'll do, in STK of SP, that's it. Okay, so push is done. Now let's define pop. So pop STK, it also belongs to the class stack. Okay, so when I cannot pop an element from the stack, when I cannot element from the stack, when it is empty, how to know where the stack is empty? When SP is -1. When it is -1, the stack is empty, isn't it? Okay, right. So when it is -1, the stack is empty. Okay, if SP equals -1, okay, right. So we'll say the stack is empty, cannot pop an element, written. Okay, right, the stack is empty, cannot pop an element. So now otherwise what we can do, we can pop the element. So first access the element, isn't it? Right. So let's access the element. The popped element is, okay, what we'll say, STK of SP. Why first access the element? Say suppose there are 5 elements, all the elements are there, 5 elements, so SP will be 4 here. So this element we have to pop. Okay, so for that what we will do, we will access the element, then we will decrement the SP. Okay, first access the element, then decrement the SP. Correct. So here we will say SP minus. So that's it. Okay, right. I hope you are trying to understand. So now what we have to do? We have to display stack. So display stack is the function, and that also belongs to class stack. So when we cannot display the stack, when the stack is empty, isn't it? So when the stack is empty, we cannot display the stack elements. So here what we'll do, now if this condition fails, then there are elements. So we'll say the stack elements are, okay, right? So here we will run a loop for int I equals sp, I greater than or equal to 0, I minus minus. Please note, move from top element till bottom element, because we are displaying the stack, okay, not the queue. So start I from sp, okay, right? So here we'll say cout stk of I and give some space. Run this. To run this, we need main function, isn't it? So there is no main function, it is saying, okay. So now let's write the main function, int main. So please note what we do, what did we do? Okay, this is totally opposite to C program, isn't it? So here in C we used to write function first, okay, but in C++ we are writing the class first. We are writing the solution first, and then we are using it in the main function. Here what we'll do is we'll use a choice equals 0, okay, right? And here we need a hash include stdlib.h, because we are exit function, okay, right? So here what we'll do, we'll use do while loop, and please note we need a object also. So stack obj, okay. So what we'll do, we'll say cout 1 push, 2 pop, 3 display stack, 4 exit program, okay. Then what we'll do, your choice, okay, we'll say enter your choice. All right, so we are making a menu based program, okay, right? Enter your choice. So what we'll do, scene choice. So what we'll do now, switch the choice, okay, right? I'll trace this program for you, do not worry, okay. So case 1, what we'll do, object dot push, okay. Then case 2, object dot pop, okay, right? Break. Case 3, object dot display stack, okay, right? Okay, break. Then case 4, we'll say cout end of program, okay. Then we will call the function exit of 0, okay, right? So then there will be a default case. So the default case will say cout invalid choice entered, okay, right? So invalid choice entered, okay. This is end of switch case, so this will be end of do while loop. So here we will write true, okay. So while, so this is it's like a infinite loop, okay, right? This is end of switch, this is end of do while loop, and this is end of main function, Okay, right. So now let's try to compile this. Yes. There's something missing, it is saying. Let's see what it is. Yeah, here we forgot to put this into, yes. Yeah, now it is compiling successfully. Now we are saying 1 push, 2 pop, 3 display stack, 4 exit program. Correct? So enter your choice. What we'll do? We'll say 2. The popped element is 3. Oh, now did you observe there? What is the what is that? See, there are actually no elements in the stack at the beginning. Okay, so yeah, we expected the 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 display should have been stack is empty. Okay, but it is popping some element. Let's display. Okay, now it is saying, okay, now try to pop. So it is saying, okay, but at the beginning when we run, it was popping an element, right? So run it again. Now I'll say display. So it is displaying some elements there. So which is wrong. Okay, it should have been better thing is, or say the correct thing was that it should have said the stack is empty. So how to do this? So let's define the constructor. The constructor belongs to the stack class. Okay, so the name of function is same as that of the class. Can you observe there? And did you observe I did not mention the return type? I did not mention the return type. So here what I'll do, sp equals -1. Okay, right, and we will say cout here a stack is created. Okay, right, a stack is created. So now let's run this. Yes, we have to end this. Yeah, see that a stack is created. Got it? Okay, right. So as soon as an object is created, it will go to the constructor. Now sp is -1. Now you say 2, the stack is empty. Now you say 3, the stack is empty. Now let's push the elements. 1, I want to push 10, and again I want to push say 20. Again I want to push say 30. Now display the 30, 20, 10. See the top element, that is first in first out. I'm very sorry, this is LIFO, last in first out. So last in was 30, so that is the first out. Okay, so now you pop, the first to be deleted is 30. Okay, before we pop, let's add one more element, 1 say 40. Again add 1 50. Now display 50. Now you try to add, but it will, now it will say the stack is full. See, the stack is full. Why? Because the capacity of the stack is 5. Now you start popping. Say 50 is popped, display it, pop. See 40 is popped, display the stack. Okay, right. Say 20, 30, 10. Again pop. Say option 2, 30 will be popped. Okay, now again display 3. Okay, again pop, again pop. Now you try to pop again, it will say stack is empty. Say try to display, stack is empty, isn't it? Right. So now let's trace the program. How does this program work? Okay, right, so that's very important for us to understand how the program works. So let's begin. See here what happens is the main will run first, as usual. Main always runs first. Okay, so there is a variable choice and we have created an object. As soon as the object is created, the control will go to the constructor. So come to the constructor. Where is the constructor? This is the constructor. So the control comes here. Okay, and now the value of sp is not, there is one object. Okay, right, there is one object here. Okay, right, so this is the object. in which we have the array like this, and we have one variable, that is sp. Okay, right? So this is the array and this is the variable sp. Okay, and this is the object, okay, obj. Okay, so this is the object here, and this is the array which we have named it as tk, and this is what it is, sp. Okay, right? Okay, so its value we made it as -1. Okay, right? So this has 5 elements as usual, the same thing that I've written on the above. Okay, so there are 5 elements, 1 2 3, okay, 4. So totally 5 elements are there in this stack. Okay, all right. The first element, okay, right? Over here we'll mark it. Okay, so this is the first element, this is the second element, right? This is the third element, and this is the, say, fourth element, and this is the fifth element. Okay, okay, so sp is -1, so this is how it will be, right? Okay, fine. So this is the object. Okay, all right, so this is the object that we have here. Okay, and this is the array within the object, and this is, so this object has two parts, one is the array and other is the sp variable. Okay, right? I hope you are trying to understand. So now next is, let's trace the program. So sp is made -1, and we will say a stack is created. Okay, so now let's run this. See, a stack is created and is giving. So now from where we left, we had left from here, we went to the constructor and came back. Now once we come back, it is printing the menu. So in the menu, now it is asking for the choice. Okay, right? So let's enter the choice. So we will say 1. So when I say 1, what happens? Choice is 1. So here there is a the comparison holds good. Okay, so object dot push, so the control is now going to push. Okay, right? In the push, what it did, it checked if sp equals 4. Now come and check here, sp is not 4, it is -1. So what happens? It will skip the if body, so now sp becomes 1. So please note here you have to change sp to 0. So sp to 0, because -1 plus 1 is 0. Okay, right? So it was -1, now we have incremented it, so it became 0. Enter the number to be pushed. So let us assume I am giving, say, 10. Okay, right? So 10 I gave, so that 10 is stored here. Say 10. Okay, right? So like this it is stored. Okay, so 10 is stored there. Now sp is 0. Please note sp is 0, which I'm not going to change there now. Okay, now next is, again after that it comes back. Where it comes back? Here. Okay, so then it will go to the break will control outside. So now it is true, so it will go and do this again. So it will print the menu again. So we have the menu again. Now it is, now let's say 3. So the stack elements are 10. How it is working? So 10 3 when I said the choice, so it is going to call display stack. So let's go to the display. In the display stack, first I'm checking sp equals -1. No, it is 0. So here it will come and say the stack elements are. So I is initialized to 0. Okay, is initialized to 0. So I, is it greater than or equal to 0? Yes. So come inside. So it will print that element 10. Now I is decremented. I becomes -1. So -1, is it greater than or equal to 0? No. So it will skip. So we have the stack elements are 10. So once the control goes out of display stack, where it comes to break here. The control is thrown off. Okay. So again it will go on to menu and so on. I hope you have understood this. Okay, how it works. So please sit and paste the program. That's very important. So for your reference, I'm going to copy this and I'm going to save it here. Okay, right? Program to implement stack using array. Now what is the next program? See, we are going to do small changes to the same program. Okay, so now what we will do is instead of setting the size of the array here as 5, we'll take the size from the user. For time being, we'll make it 50. Okay, so now we will take the size, so stack size. Okay, so stack size. Okay, all right. So now inside this, what we'll do, we will say cout enter the size of the stack. Enter size of the stack. Okay, enter size of the stack. So here what we'll do, scene size. Okay, so here we will say a stack of size. Okay, a stack of size is created. Okay, right? So here what we'll do, it is size -1. Okay, right? That's very important. That's all the changes. All. Now run it. Enter the size of the stack. It is asking. What I'll do, I'll make it only 4. Only 4. A stack of size 4 is created. Now you start pushing. Say you pop, stack is empty. Display, the stack is empty. Now insert, enter the element to be pushed. I'll say 0. Now push, enter the element to be pushed. 2, 1, 3. I have now there are 4 elements, 0, 1, 2, 3. So display them. Okay, 3, 2, 1, 0. Okay, now try to push it again. It will say the stack is full. Okay, so now exit the program by saying 4. Okay, right, put this, right? So this is a very small change I did. What did I do? Very simple. I added one variable called as size. Okay, and I took the size of the stack here in the constructor. Okay, right? So because the constructor is constructing the object, correct? Okay, so now actually what we have in the, say, how does it look like in the memory is not, see, we have this is the object, but now there are 3 variables and the stack actual size is 50. So this is 50. Okay, right? So this is 50 and there are 2 variables. This is one size and this is sp. Okay, right? So the size of this array is 50, but in that what we are doing, or we are making it work only for the 4 elements. Okay, that depends on the value of the size given by the user. Okay, the user may give 25, 30, but please note, if the user gives more than 50 as size, then our array cannot store more than 50 elements, so our program will fail. Okay, right? So the better, okay, right? So that is the next program. So program to implement an stack using a dynamic array. Okay, so mean to say we are going to create this array only after taking, so let's delete this. So here this pointer, okay, int stk pointer, so size and sp. So now see what I'm going to do. Okay, so this is the changes that we did was only so much. So only this I'm going to copy here. Stack of user choice stack as an static array. Okay, so this was the program 50. Okay, so now here what we are going to do is, now observe, going to create the stack dynamically. Okay, please observe here. So enter the size of the stack. So what we will do here, we have to now create a stack. So stk equals new int, okay, right, new int of size, creates an array of size whatever the value by the user is given. Okay, creates an array of size in heap area, okay, right? That's very important. Okay, all the things remains the same, all other things will remain the same. Okay, right, now let's run this. Now in this case, please note how it looks like in memory. Let's see first. Okay, in this case, okay, we have to delete this. Let's delete this. Okay, now please observe. Assume yeah, now assume that this is stack area and this is heap area. Okay, this is stack area, this is heap area. Okay, so what happens in the heap area? DMA, dynamic memory allocation. Dynamic memory allocation happens here in this heap area. Okay, right? So now actually we have the object here. Okay, so this is obj. Okay, so this was obj and this was sp and this is size here. This was the this was our previous program. Okay, this was the first one. Okay, both these cases the entire object is in the stack area. Okay, now what we have done is, observe carefully, there are three variables now: the pointer, size, okay, and the sp. So what is this again? This is the pointer stk. Okay, this is okay, just a moment. Let me name this as size. Okay, so this is size, this is sp, okay, and this is stk. There is a pointer. Okay, now please note where is the array? Where is the array? The array will be here in the heap. Will be here in the heap. Which array? This one. This one. Okay, the array here is in the heap. Okay, right. And this address, say 23,101. Okay, or say we'll give a small address, say 1001. So this address 1001 we are storing here. Okay. Okay, right. So this is what we are doing here. Okay, right. So as if this pointer pointing to this array. So I want you people to notice. Please note, in our first case what we did is, okay, in our first program we fixed the size of the array to, okay, and there is no variable called as size at all. Okay, so the user has to always work with the array of size 5. Okay, the user has no flexibility to change the size. But here what we did, we took a very big array of size 50 and we created a variable called as size, and the user can decide the size of the array, okay, before starting the program. But there is a problem here. Say if the user uses only 10 or 5 elements, we are wasting so much of memory. Say suppose if the user is giving a size more than 50, then we don't have sufficient space only. So this is what it is. Memory inefficient data structure. Now come to this third program, okay, of stack, where we are creating the array in the in the heap. So when we are creating, first we will take the size. Okay, so user will tell the user, give us the size of the stack you wish to create. So user will give, say, 15. Okay, right. The user will say 15. So now we will create the array of size 15. User will say 5, will create the array of size 5. User will say 50, you will create the array of size 50 in the heap area. So there is no wastage of memory at all. Okay, memory utilization is excellent in this case. So now let's run this. So I enter the size of the stack, say 5. A stack of size 5 is created. Now please note, exactly the array size is exactly 5 elements. Okay, right, and you do the operations. Okay, 10, okay, 21, 1, 1, 3, 1, 3, 2, 1. Stack is full. Display, there are 5 elements. Pop, the element is 32, pop element is 31, then 20, then 10, and stack is empty. Okay, right. So I hope you have understood this. This is very, very important. I'll save this again for your reference. You can request these materials later with me, and I'll surely send it to you. Okay, right. It is probably already saved, is it? No. Okay, yeah. So we will say, so today we have learned stack using fixed array, but allowing the user to decide about the size. But there is a problem, okay, that the size is already actually fixed in the memory. Okay, but later we created this array in the heap area, an object in the stack area. Okay, right. I hope you are trying to understand this, and next class we will begin with the stack program, and we will implement those destructors tomorrow, and we will create the object also in the heap. Okay, so we are going to use delete operator tomorrow along with destructors. I hope you have enjoyed the class. So please go through this program. As I have traced the program, you please trace the program. Okay, you can request me for the material. I can send it on a daily basis also. All right, yeah, thank you for attending the class. And tomorrow, what is that we are going to learn? I'll write it here. Yeah, tomorrow would be 28/02/2018. So tomorrow we'll be learning stack, queue, destructors and delete operator. Okay, so these are the this is our agenda for tomorrow. Okay, right? I hope you have understood this. So now what is the changes we did here? Here is this one. Okay, that's all the changes. We'll save it here. DS programs. Okay, with creation the array in heap. Yeah, thank you very much.